Hi everyone. This is a video that I've been wanting to do for a while to compare a dummy load with a coil of wire. I'll include more information in the description below, but let's take a look at what I had analyzed just a little while ago. I'm going to go ahead and load the dummy load memory slot from my RigExpert AA35 Zoom. And let's see what we have here. So this is the SWR. You'll notice that it had basically flattened out way down near a 1-to-1 match for the SWR. So go figure, that's what it's designed for. It's even giving a great SWR way down here, which is below the 160 meter band. So with that, it's also pretty low over on this side for the 35 megahertz maximum frequency of this particular antenna analyzer. So that's pretty awesome. The minimum SWR is 1.01 at 13.360 megahertz. And let's go ahead and look at another view here. Let's look at the resistance reactance chart. All right, you'll notice that the reactance is almost none all the way through here. And you'll notice that the resistance is right around the 50 ohm mark. So it's off this particular chart because it's higher than 25 for this particular view. There's multiple different views and settings with this RigExpert, but in any case, you'll see here in the yellow numbers that it is 52.43 ohms, so hence nearly a perfect 50 ohm load. So that is pretty cool, and a 1.67 positive reactance here, which would be inductance. So think about what I just showed you there, and now let's try loading something totally different. I'm going to go back to the SWR chart. We'll start there. This again is the dummy load. Let's load up the coil. So I just simply hooked up the 500 feet of wire that I showed in my previous video. And I thought, you know what, let's hook that up through my un-un, just so that I have a good connection point for the wire to my coax cable with the PL259 connector. And let's see what kind of results we get. All right, you ready? Here goes. Basically the opposite. So essentially maxed out way up near the top. So this particular frequency, 16.745 megahertz, it's at 20.89 to 1. The lowest is above the 10 meter band at 32.960 megahertz, and that's a 13 to 1. Now with an antenna tuner like mine, I could probably compensate for about a 10 to 1 difference from what I've studied and experienced. So I would say that would make it a 1.3 to 1. I'm not saying to use a coil of wire in place of a dummy load, but it's fascinating to see how this all shows up here. Now let's take a look at the next example, and that is the resistance reactance chart. So we're going to load, make sure that we are loaded up here for the coil. Yep, we are. Okay. So it's saying that resonance is at 17.071 megahertz, and so with that, it's interesting to look at the 2.40 ohms up here and the negative 305 for the reactance. Now, let's see if I can scroll through here. Okay, so you can see there's quite a change as I'm going through. It's kind of all over the place. So right there, it's almost 236 ohms of resistance and 349 almost for the positive reactance, which represents inductance when it's a positive level. It's interesting that in some places it's a negative level, which would indicate capacitance. And it's because with that coil, this is my understanding, with the coil, the wires are close to each other, separated by insulation and by air in certain cases, depending on the placement of the wires. And what's happening is the wires are generating a type of capacitor or capacitance because of the spacing with insulation in between, but then because it is a coil, it also is generating inductance. So for me, that's very fascinating to see how that all turns out, and quite interesting and somewhat exciting to think about what could be done with a coil of wire, but not just on the wire spool as shown in my previous video, but actually made into some kind of an antenna. More to come soon, I hope. All right, thank you all for watching, and 73.